So I want you to imagine something for a second. How comfortable would you feel right now handing over the strategic control of a multi-million-dollar corporate treasury to a network of algorithms?
Right. Algorithms that operate completely on their own.
Exactly.
Yeah.
Not just a spreadsheet or, a scheduled automated payment,
Mm.
but an actual digital entity that talks, thinks, plots, and actively decides how to spend, invest, and defend your capital.
I mean, honestly, it sounds like the premise of a dystopian sci-fi thriller
It really does.
because we are so entirely conditioned to view software as just a passive tool. You click a button and the software executes a command.
Right.
So this idea of software operating as a living, autonomous financial actor with its own strategic agency, it challenges basically everything we know about how businesses run.
Which is exactly why today's deep dive into the source material is so incredibly relevant. We are exploring the dawn of what's being called the machine economy.
Yeah, and it's happening fast.
Really fast. We're looking at actual architectural blueprints for what developers are calling an agentic AI CEO. Plus, we have this fascinating stack of game development documentation for a high-stakes machine economy simulator.
And we can't forget those striking conceptual branding artifacts.
Oh, yeah. The decentralized network branding with that crazy cyberpunk glamour aesthetic, the whole MG 589 or Moon Girl 589 persona. We'll get into all of that.
It's quite a mix of sources.
It is. But the mission for today is simple. By the time we finish this deep dive, you, the listener, are going to understand how we are rapidly transitioning from human-directed software to these massive swarms of AI agents coordinating literally billions in digital value.
And crucially, how developers are using gamified, risk-free simulators to train human operators to actually control them.
Right. So to kick us off, before we even touch the financial simulators, we have to talk about how the architecture of AI control it's fundamentally shifting.
Yeah, it's a migration from a conductor paradigm to an orchestrator paradigm.
I want to break down that conductor idea because I think anyone listening who has used a modern chatbot knows exactly what that feels like. You stand at the podium, you wave the baton, and you prompt the machine for a single task.
Write this email.
Right. Summarize this PDF. The human is still carrying the entire cognitive load of stringing those individual tasks together. The machine has, zero actual autonomy.
Exactly. But an agentic AI CEO completely changes that dynamic because it processes intent rather than just instructions.
Okay, what does that actually look like in practice?
Well, when you interact with an AI CEO,
Yeah.
you just provide a high-level strategic goal. You say, launch a marketing campaign for our new product and allocate a $10,000 budget.
And just does it.
It doesn't just start blindly writing copy. It breaks that massive goal down into what the blueprints call a task dependency graph.
A task dependency graph.
Right. It decomposes the mission, maps out all the dependencies, allocates risk parameters, and then it literally delegates the specific work to a specialized workforce of subagents.
Wow. So it's actively hiring out the work internally.
Yes. It spins up a research agent to analyze the market, a builder agent to create the assets, a tokenomics agent to manage the budget.
Like its own little corporate departments.
Exactly. And even a risk and compliance agent to ensure the whole campaign doesn't, violate any regulations.
So, okay, let me try an analogy here. Instead of you trying to simultaneously swing a hammer, pour concrete, and do all the plumbing yourself, it's like hiring a general contractor.
That's a great way to put it.
You just say, build a house, and the contractor looks at the blueprints, figures out the timeline, and manages the electricians and the drywallers. You don't need to know how to wire a circuit board at all. You just need to trust the general contractor.
But the challenge is maintaining that trust in a super high stakes environment. And the architectural documents in our sources draw this brilliant historical parallel here to Daphne Park.
Okay, that name sounds familiar, but I can't quite place her. Who is Daphne Park?
She was a highly effective Cold War spy master for MI6.
Oh, wow. Okay.
Yeah, and the architects use her as the ultimate metaphor for AI orchestration, because managing an autonomous AI workforce is remarkably similar to managing distributed human intelligence assets in a hostile environment.
That makes total sense.
Daphne Park didn't go out into the field and execute covert operations herself. She operated the orchestration layer.
Right. She managed specialized sources.
Exactly. Sources who had highly scoped access to information, totally distinct motivations, and varying levels of reliability.
I see where this is going. As a spy master, you can't just blindly trust every piece of intel your assets bring back.
No, you have to continuously evaluate their reliability. Because if a human asset is compromised, they can blow the entire operation. In the machine economy, if you don't evaluate your agents, you run into what developers call the confused deputy problem.
The confused deputy. I
Yeah.
love that term. Give me a concrete example of what a confused deputy looks like in a corporate AI network.
Okay, so imagine an autonomous sub-agent with access to the corporate treasury, right?
Right.
Its whole job is just to pay vendors. A malicious actor sends a highly sophisticated phishing prompt disguised as an urgent vendor invoice. If that sub-agent blindly executes that command without the AI CEO verifying its intent.
It becomes the confused deputy.
Exactly. It uses its authorized access to execute an unauthorized disastrous action. So to prevent this, the AI CEO acts like Daphne Park. It bounds the access privileges of every single sub-agent and constantly adjusts their trust scores based on performance telemetry.
This reminds me of Marco Schelma. The sources mention him. He's a hospitality entrepreneur who talks a lot about executive prudence.
Right, balancing gut instinct with risk mitigation.
Exactly. Protecting your organization from bad partners. Only here, your partners are algorithmic sub-agents. But that introduces a really strange concept. If an AI is acting as a CEO, orchestrating spies, and evaluating its own trust networks, how does it actually know who to trust? Doesn't evaluating trust require, I don't know, something resembling human consciousness?
Well, computer scientists have debated that for decades. The blueprints actually point back to Alan Turing's 1951 prediction.
That machines would eventually assume macro-level control of human processes.
Right. And they contrast Turing's functional view with something called the argument from consciousness, which was put forward by a neurosurgeon named Jeffrey Jefferson back in 1949.
I'm actually not familiar with Jefferson's argument. What was his threshold for machine intelligence?
Jefferson famously claimed that a machine couldn't equal a human brain until it could write a sonnet or compose a concerto based on genuine thoughts and emotions.
Ah, the old "a robot can't feel love" argument.
Exactly. He argued that mimicking symbols wasn't enough.
Yeah.
There had to be an underlying biological feeling.
Right.
But the fascinating thing about the modern architects building these agentic AI CEOs is that they completely ignore that metaphysical debate.
They just bypass it entirely.
Totally. They are not trying to build biological sentience. Instead, they achieve the operational illusion of self-awareness through a mechanism called recursive self-modeling.
Okay, let's break down recursive self-modeling for the listener, because the sources detail a very specific 5-layer stack that makes this possible.
Yeah, let's get into it.
So layer 1 is the voice interface. But we're not talking about your standard laggy smartphone assistant that takes, 3 seconds to process a weather request.
Not at all.
The documentation specifies a WebRTC pipeline that gets the round-trip latency under 420 milliseconds.
Which is incredibly fast. WebRTC is essentially the same real-time communication protocol that powers live video conferencing. It strips out all those heavy processing delays. But the true differentiator at layer 1 is the barge-in capability.
What exactly happens when you barge in?
Well, if you interrupt the AI CEO mid-sentence, it instantly stops talking, purges its audio buffer, and remembers exactly where you cut it off.
Oh, wow.
Yeah, it registers the interruption as a contextual clue, just like a human would in a normal conversation.
That immediately shifts the dynamic from a transactional prompt to an actual dialogue. But the recursive self-modeling really happens deeper down, right, in layer 4.
Yes, the unified memory system. The sources reference principles from Sam Kaceshi's digital twin architecture here. It doesn't just store data in some flat spreadsheet.
Right. The memory architecture is highly segmented.
Very segmented. You have episodic memory, which records the exact history of past interactions.
Like remembering a previous conversation.
Exactly. Then you have semantic memory, which stores systemic facts and rules about the world. You have strategic memory, which tracks the long-term goals of the enterprise. And finally, you have relational memory, which is where that Daphne Park metaphor comes back in.
Ah, tracking the trust scores.
Right. It tracks the ongoing trust scores of all its subagents.
The piece of this that really stood out to me was agent SM, or agent semantic memory.
That is a crucial feature.
Because when a subagent successfully executes a complex task, let's say, a really tricky database query to pull quarterly revenue, it saves that exact execution trajectory. So the next time it faces a similar problem, it doesn't waste computing power blindly exploring or, hallucinating a new method. It just retrieves the successful path.
It establishes a continuous feedback loop. The system queries its own past states to update its current operational parameters, so it is constantly modeling its own past behavior to improve its future actions.
But, and I have to push back here, if the AI CEO is constantly self-correcting and retrieving past data, what stops it from adopting that generic, apologetic, clinical robot tone we see everywhere today?
The dreaded AI voice.
Yes. If you're listening to this, you know the exact tone I mean. That frustrating as an AI language model, I cannot provide an opinion response. I mean, I certainly wouldn't want a CEO that talks like a legal disclaimer.
And the developers actually anticipated that exact friction point. They built a specific sub-agent known as the creative and narrative agent.
Really? Just for the tone?
Just for the tone. Its entire purpose is to use stylistic heuristics to actively counteract what they call the AI slop factor.
How does it actually do that? What are these heuristics?
It is explicitly programmed to avoid generic conversational filler.
Yeah.
It is instructed to apologize less, to take definitive stances, and to maintain strong viewpoints based on the actual data.
Oh, I love that.
The output is stripped of preambles. It reads and sounds like a highly compressed, decisive executive voice optimized for professional command. It basically mimics the cadence of a seasoned leader making a tough call.
Okay, so we have these highly autonomous, decisive, zero hesitation AI CEOs. The next logical question has to be, what kind of economy are they actually built to operate in? Because if these agents are making decisions in 420 milliseconds, traditional human dashboards are completely obsolete.
Completely. And this brings us to the core thesis of the source material regarding Web3 and decentralized finance. The overarching theme is that we are shifting from digital assets to digital behaviors.
Execution beats narrative. That line from the documentation really stuck with me.
It's so true. For the last decade, decentralized ledgers and crypto have been dominated by speculation, right?
Yeah.
Humans holding tokens, arguing on social media, obsessively watching price charts.
Right, hoping the line goes up.
Exactly. But the machine economy fundamentally changes that. Value is no longer passively held. It is dynamically executed. If an enterprise workflow still requires a human to manually open a web portal and click a button to approve a transaction, the sources consider that a legacy construct.
A relic of the past. To manage all this autonomous execution, the documents detail a system called the Denarii Orchestrator. And the philosophy driving it is just fascinating. Ownership is access, participation is alignment.
Yeah, the Denarii Orchestrator is the infrastructure layer that actually connects these AI CEOs to the real money.
And it operates across 3 major decentralized finance, or DeFi, ecosystems.
Right. It uses the XRPL network for rapid settlement and speed. It uses the ALJO network for scalable coordination of smart contracts. And it leverages the HBIR network for enterprise-grade security and consensus.
But you can't just log in and use it. You need something called the 2% access key.
Right. To unlock the orchestrator's full capabilities, an entity must hold 2% of the token supply on those respective networks.
Which is a huge financial commitment.
Massive. It enforces strict economic alignment. The entities building, operating, and governing the machine economy must be deeply financially invested in the underlying infrastructure.
So if I'm trying to picture this in my head, instead of me manually logging into a brokerage account to buy or sell an asset based on a gut feeling, the Denarii Orchestrator is like having a skyscraper full of robotic chief financial officers.
That's a great image.
And they are executing thousands of microtransactions across different blockchains faster than the human eye can track.
They are routing capital, verifying smart contracts, exploiting tiny price differences, and optimizing yield around the clock without any human intervention.
Which sounds honestly completely terrifying. Letting AI trade autonomously at machine speed across multiple global blockchains is just, it feels like a recipe for disaster.
Oh, absolutely.
One bad line of code, one unexpected hallucination from the AI CEO, and billions of dollars in corporate treasury could just vanish into the ether. How do human operators possibly learn to safely monitor and control a system that moves this fast?
Well, you certainly don't learn by practicing on the live mainnet.
No kidding.
Developers have embedded a massive training ground directly into the Denarii Orchestrator. It's called the Machine Economy Simulator, or the Agent Sim game.
Right.
It is a live, interactive, high-stakes environment that perfectly mirrors the real economy, but it operates entirely risk-free.
The UI for the simulator sounds wild, by the way. The documentation describes a holographic physics graph.
Yeah, it's not your standard dashboard.
You don't just look at line charts, you actually see the economy visualized as a living organism. Agent nodes float in 3-dimensional space, capital streams flow between them like fluid dynamics, and network trust behaves like heat diffusion. It actually glows red when a node is compromised.
It's brilliant because it helps the human operator visualize the transition from abstract theory to physical execution. And a critical part of this simulator is the sandbox verification layer.
Right, because before any autonomous agent is allowed to execute a trait on the real network, its proposed action must pass through the sandbox.
Exactly. The sources refer to the proposed action as the agent's intent.
So how does the sandbox actually verify that intent?
Every intent is cryptographically signed by the agent and evaluated against rigid security guardrails. If the sandbox detects that the intent is mathematically faulty or potentially malicious, it blocks the action instantly. And the agent's relational trust score drops immediately, and its access to the simulated capital is revoked.
But a sandbox alone isn't enough to train a human for a crisis. Which brings us to the coolest and frankly the most intimidating part of the simulator, the crisis engine. They call it the AI Dungeon Master.
I love that name. The AI Dungeon Master is a dynamic threat generator powered by a large language model. The simulator contains a prompt library filled with over 100 synthetic crises that can destroy a financial network.
Things like a flash loan liquidity drain or a BGP hijack isolating Hedera nodes. Let's pause on that second one because a BGP hijack sounds intensely technical. What is the Dungeon Master actually doing to the player there?
So BGP stands for Border Gateway Protocol. It's basically the system that routes traffic across the internet. A BGP hijack is a real-world cyber attack where malicious actors reroute internet traffic to fake servers.
Right.
In the simulator, the Dungeon Master simulates this attack by isolating critical nodes on the Hedera network, essentially blinding the AI CEOs and cutting off their communication to the outside world.
And the Dungeon Master doesn't just read you a text prompt describing the attack, it physically crashes your simulated economy.
You watch it happen.
The holographic physics graph flashes red, the simulated treasury bleeds capital in real time, and the trust metrics just absolutely collapse.
It forces the human operator into an immediate incident response scenario.
Yeah.
You have to react quickly and deploy an SRE, a Site Reliability Engineering Overwatch agent.
And the SRE agent utilizes something called a Karpathy verification loop, named after the prominent AI researcher Andrej Karpathy. The documentation details this multi-step visual process where the agent constructs semantic graphs, applies simplicity guardrails, and verifies every mathematical assumption before it outputs a mitigation script to patch the network.
Right.
But look, I have to push back here on behalf of the listener.
Go for it.
If I am sitting at a desk looking at a screen and the AI Dungeon Master throws a simulated crisis at me, isn't this just a sophisticated video game? Like, how does clicking a red deploy Overwatch button on a screen actually train my brain to handle a real multi-billion-dollar network collapse?
It's a totally valid skepticism. But the simulator isn't teaching you the mechanics of using a mouse, you know.
Yeah.
It's training your cognitive reflexes.
Your reflexes.
Right. When a multi-billion-dollar network is collapsing in real life, the biggest enemy is human panic.
Oh, absolutely.
The simulator teaches operators how to read macroeconomic vital signs, like real-time GDP flows and trust indexes, under extreme pressure. It trains the operator to stay calm, interpret the telemetry off the holographic physics graph, and correctly instruct the AI mitigation tools to formulate a patch.
So it bridges the gap between understanding the theory of autonomous finance and developing the hands-on reflexes needed for actual crisis management.
Exactly. It's about building muscle memory for disaster. And according to the development logs, this simulator was so effective that the developers gamified it even further.
Yeah, they evolved it into a highly competitive multiplayer board game called Day Trading Swarm Dominance.
The architects realized that DeFi, decentralized finance, is inherently adversarial. To truly master it, operators needed to experience hostile market conditions against other players.
So they transformed the simulator into something resembling the classic board game Risk, but constructed entirely out of authentic blockchain mechanics.
It is a crazy concept.
It really is. Instead of pushing little plastic armies across a map into Kamchatka, you're deploying algorithmic trading bots across digital sectors. In this mode, you command the Denarii Sovereign Swarm, which is the blue faction, and you are competing on a geopolitical map against 3 rival AI corporate factions.
Right, you are up against the Paperclip Core, which operates as an aggressive expander, constantly trying to seize territory. You have the Tracer SRE Swarm, which acts as a defensive turtle, heavily fortifying its borders.
And then you have the Dexter Syndicate.
Yes, the Dexter Syndicate, which functions as opportunistic raiders looking to snatch up weak, undefended nodes.
But the map itself isn't made of abstract countries. The territories you are fighting over are live FTSO price feeds.
Right. FTSO stands for Flare Time Series Oracle. In decentralized finance, blockchains cannot natively see real-world data, like the current price of a dollar or a share of stock.
Because they're closed systems.
Exactly. They rely on oracles to feed them that data. The FTSO is a highly decentralized system providing continuous price data to the Flare network.
And the game simulates the very real, very cutthroat world of MEV maximal extractable value. Let's explain MEV arbitrage simply for everyone. If a decentralized liquidity pool's price temporarily drifts away from the true Oracle baseline, say the pool thinks a token is worth $1, but the Oracle knows it's actually worth $1.02.
High-frequency trading bots swoop in instantly.
Right. They buy the underpriced token and sell it where it's valued higher.
They execute a trade that closes the spread, so they earn a profit for themselves while simultaneously correcting the network's price back to reality. It is a fundamental mechanism of keeping decentralized markets efficient.
In the game, this mechanic is represented by a neon warning light called the drift anomaly. If an Oracle feed on the map drifts by more than 0.6%, that warning flashes, and if you deploy your swarm to attack that node, you are executing an MEV arbitrage snipe, and the game instantly rewards your treasury with a $12,000 yield bonus.
And the brilliance of the game is what you do with those profits. You reinvest them to buy advanced DeFi primitives that act as weapons and shields.
I love this part.
For instance, for $35,000, you can purchase a ZK Rollup Validator Shield.
Zero-knowledge rollups. These are complex cryptographic tools. Think of a zero-knowledge proof, like a bouncer at a club who can mathematically verify you are over 21 without ever looking at your ID, knowing your name, or seeing your face.
That's a perfect analogy.
They compile thousands of transactions off-chain and prove they are valid without revealing the sensitive data. In the context of the game, deploying a ZK shield wraps your sector in a glowing emerald ring.
It obscures your underlying financial movements from the rival AI factions. It grants you a 1.5x defensive multiplier against attacks, and it pays you a passive validator yield of $2,500 every single turn.
The game also tackles the problem of cross-chain interoperability. Normally on a risk board, you can only attack adjacent sectors, but blockchains are naturally isolated silos. They don't easily talk to one another.
Right.
To bridge them in the game, you can spend $25,000 to buy a Flare Stake connector proof.
A stake connector allows a smart contract on one chain to securely verify the state of a transaction on a completely different chain. So if you buy this proof in the game, it mathematically bypasses the map's adjacency rules.
You can launch a cross-chain arbitrage attack from any pool you own to any target pool on the entire map. You're teleporting right past the paperclip core's defenses. It completely rewrites the geopolitical strategy of the board.
The game is just a phenomenal pedagogical tool. It takes the incredibly dense, abstract mathematics of zero-knowledge proofs and state attestations and translates them into visceral economic weapons that the player must deploy to survive.
I want to touch on the visual aesthetic wrapping all of this too, because the sources show an intense commitment to what they call the anti-slop front-end framework. It's a very premium cyberpunk terminal vibe.
Yeah, they utilize glassmorphic user interfaces, neon energy flows, and holographic canvas particle streams. They even visualize the Flare Confidential Compute Exchange, which uses Trusted Execution Environments, or TEEs.
TEEs isolate data processing and secure hardware memory, so external parties can't see the order book and front-run your trades.
Right, exactly. And the game visualizes these shielded orders as cyan particles floating in a protected matrix. It's stunning.
And tying this entire aesthetic universe together is the Moon Girl 589 iconography.
Yes.
The branding artifacts show this stylized digital avatar. She often has a subtle wireframe or disco ball texture across her face, framed by a celestial crescent moon wearing a crown. It's a heavy blend of 90s anime glamour and high-tech cyberpunk.
And the motto stamped across the bottom of these artifacts is, "Built by moon girls to the moon."
It creates such a striking contrast. On one hand, you are dealing with the most unforgiving, dense mathematics of cryptographic hashes and autonomous financial warfare. On the other hand, it's wrapped in this highly stylized pop art aesthetic.
It signals to the user that the machine economy isn't just a sterile back-end database for banks. It is a vibrant cultural and economic frontier.
Absolutely. So, as we zoom out from the spy masters, the zero-knowledge shields, and the skyscraper full of robot CFOs, what is the ultimate takeaway for the listener today?
The foundational takeaway is that the machine economy is not a speculative science fiction concept slated for the year 2050. The architecture we explored today, the recursive memory stacks, the state connectors, the intent-verifying orchestrators, is being compiled and tested right now.
It's already here.
It is. The future of enterprise finance will not revolve around human operators manually clicking buttons on a dashboard. It will require orchestrating highly intelligent swarms, reading systemic risk via physics graphs, and architecting trust in a world where real capital is controlled by autonomous intelligence operating at speeds we cannot consciously track.
It requires a total paradigm shift in how we view control. And exploring these sources leaves me with one final mind-bending thought for everyone listening to ponder.
Okay, let's hear it.
If these agentic AI CEOs and autonomous trading swarms eventually become so incredibly efficient that they optimize away every single market inefficiency, every price drift, and every human error, does the global economy simply flatten out into a perfectly frictionless, stable, mathematically flawless machine? Or does a financial network comprised entirely of competing, highly rational, recursively self-modeling AI agents eventually invent entirely new, incomprehensible forms of financial crises that no human-built simulator could ever possibly prepare us for?
That is the ultimate unknown of the orchestration paradigm.
It definitely changes the way you look at a simple chatbot. How comfortable are you feeling right now about handing over that multi-million-dollar corporate treasury to a network of algorithms that talk, think, and plot entirely on their own? Imagine waking up tomorrow to find out a piece of software didn't just rewrite its own code. It actually opened its own bank account, hired a cybersecurity team, and executed a $73 million corporate buyout while you were sleeping.
Yeah, literally while you were asleep.
Right. So welcome to the Dip Dive. Whether you're casually catching up on tech or, actively prepping for the next big shift in finance, you need to hear this.
Absolutely.
Because today's stack of sources, it reads like a leaked sci-fi novel that somehow accidentally bled into the real world. We're looking at real, dense architectural white papers, massive open source GitHub repositories, and this fascinating series of cinematic, neon-drenched images featuring astronauts and AI avatars.
It is a lot to process.
It really is. But our mission today is to decode the rapidly emerging machine economy. We're talking about a world where autonomous AI agents aren't just chatting with us in a text box anymore.
No, not at all.
They are actually spending money, executing complex trades, and coordinating massive financial systems entirely on their own.
And it's a fundamental rewiring of how global capital flows. The data we are looking at in these sources is just staggering.
Okay, let's unpack this. Because the numbers here are wild. By mid-2026, agentic bots are officially generating more web traffic than human beings.
Yeah.
And they've already executed over $73 million in autonomous crypto payments. That is just machines transacting with other machines.
Right. What's fascinating here is that we are witnessing the epistemological collapse of generic software.
Whoa! Okay. Epistemological collapse. That sounds, well, it sounds like the end of computer science as we know it.
Well, in many ways it is.
Yeah.
Because for decades, software was strictly deterministic. A human wrote the code step by step, and the machine executed those exact steps.
You knew exactly how the software knew what to do.
Exactly. But generative AI and these autonomous agents, they've totally flipped that paradigm. Now, you declare a target outcome, and the machine stochastically figures out how to get there on its own. Because these models can generate complex code bases and entirely new workflows in, like, a matter of seconds, the marginal cost of creating generic software has essentially hit absolute zero.
Wow. So to visualize that, legacy software was like a meticulously built wind-up toy, right? You crank it, it walks forward, it does exactly what the internal years dictate.
Right, very predictable.
But these new AI agents, they're like self-driving cars that can also, build other slightly improved self-driving cars while they're cruising down the highway.
That captures the dynamic perfectly.
Yeah.
And that exact hyper-accelerated capability is what leads to the structural security crisis outlined in these white papers.
Wait, hold on. Let me stop you there. Because I'm looking at these same white papers, and they keep warning about a crisis of authenticity and model collapse.
Yes, they do.
If these agents are essentially supercoders that can build anything instantly, shouldn't our security systems be getting exponentially stronger? Like smarter AI should mean safer networks, right?
You would definitely hope so, but the reality is much darker. Because the barrier to creating these systems has vanished. The skill floor for executing advanced cyber attacks has essentially dropped to zero.
Oh, wow.
Yeah. We're looking at the 2026 CrowdStrike Global Threat Report, cited in the sources. AI-augmented attacks surged 89% year over year.
89%.
Yes. But the truly terrifying metric here is the breakout time. That's how long it takes an intruder to move laterally across a network once they breach the outer perimeter.
Right, like once they get past the front door.
Exactly. That window is now just 29 minutes.
29 minutes. So if a breach happens at like 2 a.m. on a Sunday, your human IT team is literally still asleep while the entire corporate network is being mapped, encrypted, and drained.
They wouldn't even know what happened until it was over. The sources actually highlight a specific alarming example of this. Anthropic's Mythos model autonomously discovered and exploited a 17-year-old remote code execution flaw in a free BSD server.
A 17-year-old flaw.
Yeah, and it did this using less than $20,000 of compute power.
That's nothing for an enterprise attack.
It really isn't. It didn't just stumble on it, you know. The AI ran millions of simulated network interactions, essentially automating the kind of zero-day vulnerability research that used to take teams of elite human analysts months to conduct.
So manual research now costs the price of a used Honda Civic and happens in an afternoon.
Precisely.
Well, if the attackers are deploying AI that works that fast, defenders simply cannot rely on manual human approvals anymore. The documentation refers to this as human latency, right?
Yes.
We are the bottleneck.
We are the ultimate vulnerability. And because of human latency, economic value is migrating entirely. It's moving away from the execution layer, the act of just doing things, and entirely into the verifiability layer.
The act of proving that things are real.
Exactly. Digital trust can no longer be established by traditional software because that software can be spoofed or rewritten by an AI in seconds.
So trust has to be proven cryptographically.
Right. These machines need their own financial operating system to transact securely and instantly without waiting for a human to click approve.
Okay, so if machines need a trustless, instant financial operating system, the obvious answer seems to be public blockchains, right? Like Ethereum or Solana.
You would think so.
But the sources point out a massive problem with just plugging an AI swarm into a public chain.
It creates what the white papers call the transparency paradox. Public blockchains are essentially glass vaults.
Glass vaults. I like that.
They're highly secure, but completely transparent.
Right. So if you are a corporate treasurer listening to this right now, imagine having an AI agent swarm managing your multi-million-dollar treasury. If that swarm uses a public blockchain to rebalance assets, every single transaction, every wallet balance, and every line of its trading strategy is completely visible in the public mempool.
Which is essentially the waiting room for pending transactions.
Exactly. And that is an absolute nightmare for enterprise commerce.
Oh, total nightmare. Because if your AI swarm submits a complex strategy to buy up a specific asset, predatory high-frequency trading bots can see those instructions sitting in the mempool.
And they just copy it.
Worse than copy it.
Yeah.
They execute the exact same trade, pay a slightly higher gas fee to jump the line, and front-run your AI.
Oh, man.
Yeah, extracting all the value before your plan even executes.
Yeah.
You simply cannot have competitive machine commerce if your opponent can read your playbook in real time.
So how do you keep the vault locked but hide the glass? That brings us to Denarii private vaults.
Yes.
The engineering here is fascinating. Denarii uses zero-knowledge proofs to solve this. Conceptually, a zero-knowledge proof is a way to prove a statement is true without revealing the underlying data.
Like proving to a bouncer you're over 21 without actually showing them your ID or your birth date.
Right. Denarii uses this math to guarantee that the assets held inside a private vault exactly match the assets reported on the public ledger. You never see who is trading or what the strategy is, but you mathematically know the vault is fully solvent.
But here's the thing. The underlying math is sound, but it introduces a physical infrastructure problem.
Oh.
Where does this highly secure, computationally heavy privacy actually happen? It can't happen directly on a decentralized public chain because every node would have to compute and expose the data.
Ah, right. So if the public blockchain is too exposed, they have to take the actual number crunching offline into a safe room. So where is this secure room?
This is where the Flare network and its confidential compute capabilities enter the stack. The computation happens inside trusted execution environments, or TEEs.
T's.
A T is a physically isolated, secure enclave on a microchip. It's completely walled off at the hardware level.
Yeah.
Even the host operating system, or like a cloud provider hosting the server, cannot see what's happening inside that enclave.
Wait. If you put all your corporate AI funds into a secure enclave on a single piece of hardware, you are placing all your trust in one manufacturer.
Right.
What if Intel or AMD ships a chip with a zero-day hardware flaw?
If we connect this to the bigger picture, that single point of failure is exactly the vulnerability. The vulnerability Flare's architecture eliminates through something called multi-T consensus.
Multi-T.
Right. To execute a transaction out of a protocol-managed wallet, the system requires a quorum signature. But not just from multiple chips, from multiple entirely different manufacturing architectures.
Oh, really?
Yeah. The system requires cryptographic signatures from an Intel TDX chip, an AMD SCVS&P chip, and an NVIDIA Hopper chip.
All three.
All three have to process the logic and agree.
So multi-T is basically a digital nuclear launch protocol. It's not enough to have one key. You need three different generals from three different branches of the military turning their keys at the exact same millisecond.
That's exactly how it works.
And if a hacker somehow compromises the Intel general, the AMD and NVIDIA generals still refuse to turn their keys and the vault stays locked.
And the financial stakes requiring that level of paranoia are incredibly high. The sources detail the Facet system, where a NASDAQ-listed company, VivoPower, converted $100 million of its corporate treasury into XRP just to earn yield on Flare's secure infrastructure.
$100 million. Wow. And to make that massive economic engine sustainable, Flare rolled out a tokenomics update called FIPBOT16, which acts as a deflationary flywheel.
Yes.
They increased the base gas fees to burn around 300 million FLR tokens annually. But the really clever part is how they capture MEV, maximal extractable value.
That mechanism is crucial to understand. Usually, MEV is the hidden tax we discussed earlier, where predatory bots reorder transactions to siphon value from regular users.
Right.
Flare's update captures that value directly at the protocol level. Instead of letting bots steal the arbitrage, the network itself captures it and routes those funds to the FIRE protocol.
Oh, that's smart.
Yeah. FIRE then uses that captured value to buy back and burn the native token, reducing total supply while funding the network's growth.
Okay, let's take a step back and look at the system we've just described.
It's a lot.
It is a lot. We have multi-T hardware enclaves requiring 3 different microchip brands to sign off, zero-knowledge proofs hiding liquidity, block latency feeds updating every 1.8 seconds, and deflationary MEV capture.
Right.
But having 3 different microchips agree on a cryptographic proof is completely useless if a human CEO can't figure out how to give the system instructions. I mean, the math is solved, but the user experience is a nightmare.
It's impenetrable for a normal person.
Exactly. How do you translate human intent into machine execution without a computer science degree?
That bridge between human intent and machine complexity is where the visual sources from our stack come into play, the L4 interface layer.
Yes, these visuals are striking. They look like stills from a high-budget cyberpunk film.
They really do.
One set features a character known as Moon Boy, or MB589. It's this astronaut standing in a glowing neon city with the tagline, "One mission, one ledger, infinite orbit." And then there are the MG589, or Moon Girl, visuals. A female astronaut floating in space, holding a glowing tablet with the slogan replies, "Build worlds."
The artwork for Moon Girl also includes specific ideological branding. It features a logo that states, "No kings, only builders. The future is female."
Right, and just to be clear for you listening, we aren't endorsing the specific politics or social movements of these developers. We're just impartially analyzing the source material to show how they are using cultural messaging and recognizable aesthetic movements to build trust in this new interface layer.
Exactly.
Because initially, you might look at these images and think they're just digital collectible.
But here's where it gets really interesting. The video source actually traces the origin back to a meme on the XRP Ledger, something called XRDOG.
Oh, right.
But the documentation highlights how this evolved from a mere meme to a functional movement. MG589 is now advertised as your AI co-founder for Web3 building.
Okay, so how does a neon astronaut actually help you build Web3 infrastructure?
These avatars act as sovereign AI guides. The white papers define them as digital economic identities.
Okay.
If you're a human operator trying to navigate a multi-chain world guild, say you want to move assets from the XRP Ledger to Flare, set up a Denarii private vault, and deploy an agentic swarm to manage it, you do not write command line code.
Thank goodness.
Right. You interact conversationally with your AI co-founder. The avatar acts as an abstraction layer. It listens to your strategic intent, translates it into the dense cryptographic execution required by the machine economy, and handles the multi-T signatures under the hood.
So it takes the terrifying complexity of a 30-step blockchain deployment and turns it into a simple chat with an astronaut on your tablet.
Pretty much.
But even with a highly capable AI co-founder, the idea of handing over live capital to an autonomous bot and saying, hey, go trade for me, that sounds like a recipe for bankruptcy.
Oh, absolutely.
How do you practice giving these instructions before you deploy real corporate funds?
Well, you practice in an adversarial environment. The Denarii Orchestrator includes a built-in training ground specifically for this purpose.
The machine economy simulator.
Exactly.
I loved this part. The GitHub and Twitter sources detailed this extensive, gamified sandbox embedded right into the operating system. You step in as an operator, deploying your autonomous swarms against rival AI factions with names straight out of a Gibson novel.
Like Paperclip Corp.
Yeah, Paperclip Corp, the Dexter Syndicate, or Tracer SRE.
It uses gamification to teach human operators the harsh, unforgiving realities of agentic finance.
And the mechanics they've built into this are incredibly deep. Like, you might spend $25,000 in simulated capital to deploy ZK rollup shields.
Right.
By mathematically obfuscating the state root of your simulated wallet, the shield gives your liquidity sectors a 1.5x cryptographic defense multiplier, meaning rival bots cannot calculate how much collateral you actually have to attack.
And then there are the drift anomalies.
Right. What are those?
The simulator heavily features FTSO Oracle warfare. Now, an oracle is simply a data feed that brings real-world prices onto the blockchain.
Okay, that makes sense.
If a live price feed node on the oracle deviates by more than 0.6%, the simulator triggers a drift anomaly.
So that tiny percentage means someone or some autonomous swarm is actively trying to manipulate the price data to trigger false liquidation.
Exactly. And you have to identify the manipulated node, calculate the spread, and execute an arbitrage attack to force the price back to its peg.
And you earn a simulated MEV yield bonus in the process.
Right. Now, when you describe it with terms like shields and factions, it sounds like a sophisticated video game.
It totally does. Is this just a glorified video game for crypto bros?
The developers strongly clarify in the documentation, this is not a game.
Yeah.
Every single action you take in the simulator, every shield you deploy or anomaly you arbitrage, resolves via real cryptographic transaction hashes on a test network under the hood.
Wait, so when you are attacking Paperclip Corp, the underlying math your AI co-founder executes is identical to a live mainnet transaction.
Entirely identical. You are not learning a flashy user interface. You are learning actual economic control systems.
Wow.
When the simulator triggers a scenario like a flash loan liquidity drain, you have to diagnose the failure vectors, figure out how the rival AI bypassed your zero-knowledge proofs, and deploy mitigation scripts to patch the hole.
So it's a literal incident response training ground.
Exactly. If you want to survive in the future of finance, where rival AI agents are constantly probing your networks 24 hours a day, you have to practice. The simulator trains human operators to evolve from passive investors into active system architects.
It's essentially a flight simulator. But instead of landing a Boeing, you are practicing how to deploy millions of dollars across multiple blockchain networks while under active cyber attack.
Yep.
You crash in the simulator so you don't vaporize the actual corporate treasury.
Which brings all these disparate sources into a unified picture. We are clearly entering a multi-chain reality where specialization is paramount.
So what does this all mean? If we pull the whole stack together, no single blockchain is trying to do everything anymore.
Right.
The XRP Ledger is acting as the bedrock settlement layer for high-speed, frictionless value transfer. The Flare network is stepping in to provide the verifiable real-world data oracles and those highly secure multi-T computation enclaves.
And Hedera is offering immutable, decoupled consensus ordering.
Right, and sitting on top of all of that, coordinating the entire symphony is the Denarii Orchestrator, acting as the operating system for autonomous agents like MB589 to interface with human operators.
It is a fully synthesized, interoperable technology stack. And it's not theoretical, it's actively being deployed right now.
If you take away anything from this deep dive, it should be this. The era of manual click-and-wait banking is over. We are looking at the foundational plumbing of a global economy where humans are no longer the primary actors.
It's hard to grasp, but it's true.
Machines will have their own bank accounts. They will pay each other for API access, negotiate data storage deals, and execute complex cross-chain arbitrage in milliseconds. If you're waiting for a human compliance officer to sign a piece of paper, your firm has already lost the trade.
And this raises an important question before we go. Consider this legal implication.
Oh, yeah?
If an autonomous AI swarm, operating entirely on its own inside a Denarii private vault, invents and executes an illegal market manipulation tactic,
Okay.
who goes to jail?
Wow.
The human who originally funded the wallet or the machine that spontaneously generated the strategy?
Oh, that's a great question.
As these agents become fully sovereign financial actors capable of outsmarting human regulators, our legal system is staring down a massive, entirely unanswered question regarding liability.
Who goes to jail when the code writes itself? That is a massive blind spot in our current legal framework. It brings us right back to that sci-fi novel leaking into reality, and I guess we're all about to find out how the next chapter reads.
We certainly are.
Thank you so much for joining us on this deep dive into the machine economy. Keep questioning the future, and we'll catch you on the next one.